All right, so section 5.1 is on the mid-segment theorem and coordinate proof. And we have a nice cool picture of a battleship right here because that's what coordinate proofs are like. They're like battleship. Mid-segment is a segment that connects the midpoints of two sides of a triangle. So here we have point M, which is the midpoint of segment AB, and we have point N, which is the midpoint of segment BC. And line MN is therefore called a mid-segment. Every triangle has three mid-segments. So if we find the midpoint of AC, then we can see that line MP is going to be a mid-segment and line NP is going to be a mid-segment. The mid-segment theorem says that if this segment XY, if X is a midpoint of AB and Y is a midpoint of AC, then the mid-segment is parallel to the third side and half the distance of the third side. So right now, segment XY is parallel to segment BC, and if XY is 5 in length, what would length BC be? 10. If length BC was 17 in length, what would XY be? It would be 17 over 2. So that's the mid-segment theorem. Coordinate proof is going to involve taking an object and putting it in the Cartesian plane and then using formulas to calculate distances and then explain what you find. So coordinate proofs are kind of nice if you like to use formulas. So here we have a problem that says we want to prove that the diagonals of a rectangle are congruent, and we're going to do a coordinate proof on this. So to start off with, we're going to need to know where to locate the figure. And generally speaking, the best place to locate a figure is either going to be in the first quadrant or centered on the origin. In this case, I think I want to always try putting it in the first quadrant first. You'll notice that even in the first quadrant we have variables that are unknown. The B, the Y value, how high is this triangle or rectangle? We don't know that, but it can be represented with the B. And you'll notice that the B is represented in both this top point on the left and the top point on the right. They both have a coordinate of B for the Y value because it's a rectangle. Just like the top right corner, A is the X value, and the bottom right corner, A is the X value, because they're both the same distance to the right of the origin. So once we put the object in the Cartesian plane, then we're going to use some formulas. So in this case, I'm going to use the distance formula to talk about what length RC is, and the distance formula to talk about what length ET is. You'll notice that when I plug in the X sub 1 and Y sub 1 and X sub 2 and Y sub 2, I can then do my calculation and the zeros are going to bounce out, and we now know that length RC is equal to the square root of A squared plus B squared, and length ET is equal to the square root of A squared plus B squared. So they're both equal to each other. And this is the proof that that the diagonals of a rectangle are congruent. Our explanation is going to be to use some words. So we would write something like, since the lengths of the two diagonals are equal, then they are congruent. And that would be an example of a coordinate proof.